Hello, in this quick video, I'll be talking about my research project on growing agents. Let's dive right into it. So what do I mean by a growing agent? Well, simply put, the agent's policy neural network can increase in size over time. In my work, I do this by increasing the hidden size of a three-layer neural network one at a time. In my experiments, I use the Lunar lander environment from OpenAI Gym. I modified the environment to parameterize it. The 6 parameters are shown in this table. Let's look at these two examples. On the left is what I consider to be an easy environment, and on the right is a more challenging one. Now, let's take a look at the algorithm. An agent manager is paired with an environment, and the initial parameters are set. Over time, agents use a genetic algorithm to learn to solve the environment. Once it is solved, a new environment is generated by mutating the current one and using a selection process similar to that in POET. The interesting part, though, is determining when the agents should grow in the learning process. The agent manager maintains the current hidden dimensions and the age of the agents, and also keeps track of the current elite and the best elite so far. Let's say we trained the agents for n steps and we end up at this point where the hidden dimension is 4 and the age is 9. At the next step, 3 things can happen. First, the new elite scores higher than the best elite so far, in which case the age is reset to 0 and the best elite is replaced with the new elite. Second, the new elite is better than the old elite but not as good as the best elite found. In this case, the age remains the same and we can continue our training. Third, the new elite scores worse than the previous elite, in which case the age goes up by 1. Since the age is now at 10, the neural network grows by 1, and the age is reset to 0. Through experimentation, I determined that age 10 works best so that progress towards solving an environment does not stagnate for too long, while also giving the agents enough time to improve. I evaluate my work by answering 2 questions. 1. Do more difficult environments require larger neural networks to solve them? And 2. How do agents perform on novel generated environments? To simulate a population of agent environment pairs without utilizing the large amount of resources and time to train POET, I decided to simply create 5 different environments with varying parameters and ran them simultaneously. So, do complex environments require larger networks? Yes. Environment 1 and 2, which are the easiest to solve, were solved with a hidden size of just 1. Environment 3 was solved by an agent with hidden size 3, environment 4 with a hidden size of 18, and environment 5 with a hidden size of 7. To dive deeper, let's consider environment 5. With a small hidden size, the agents performed very poorly, but as the hidden size went up, so did the scores. The environment was solved at step 316 with a hidden size of 7. Next, let's see how agents performed on subsequently generated environments. Here we see that environment 2 was solved with a hidden size of 1. The next generated environment was more complex and the agents grew to a hidden size of 3 before being able to solve it. After this, the agents were able to solve several environments very quickly with a network of the same size with the same hidden size of 3. Finally, I compared 2 runs that both solved the same environment 1 in this case. I tested the agents on a set of 1000 environment instances with fixed parameter values. The results are on the right. Comparing the 2 reward distributions, we have a p-value that is significantly smaller than 0.05 on the Mann-Whitney U test, indicating that both the runs performed similarly. Because the subsequent environments have different environment parameters, it is not meaningful to compare the agents that solve them. To conclude, in this work, I presented a never-ending RL method with a novel training regime where the agents can grow as the environments evolve. As future work, it would be interesting to see how agents transfer between environments, like in POET, and more diverse ways of modifying the policy network, such as by reducing the hidden size or adding skip connections across layers. So that was my project on growing agents. I hope you found it interesting. The code is linked below in the description. And thank you for the opportunity.